Good afternoon. Last session for today. So I'm Michele Bustamante, and I'm about to talk really fast for 1 hour because we're going to cover 6 platforms and talk about orchestration and scheduling and whether or what the features are that you might care about. So I called this Embracing Docker Simplicity and Harnessing Platform Power, mostly because there are ways that you can leverage Docker in deployment scenarios that don't involve orchestration. And then there are things that orchestration gives you, platforms give you, that you might find advantageous in certain solutions, usually in larger scale solutions in particular. And in those cases, you need to invest in more. So we want to get a taste of what do those orchestration platforms do, and at the same time maybe see a few different platforms along the way. So I will proceed to frequently asked questions that I get all the time. One of them is, how do I know if I need an orchestration platform? It's a very good question. So that is a question that I will not be answering, simply put, because you cannot answer it globally. But what I can do is show you the things we might care about that help you decide. So we're going to do that. The other question is, how do I choose the right approach or platform? So, once I know that I need a platform, which one do I choose? And that's another question that I will not be answering. So I'm starting really firmly at the beginning of the talk with 2 things I will not do for you. But the reasoning behind that is that it's very difficult. It's a finessing process. You have to understand the customer and the culture they have, and if they have affinity to a certain platform already, and so forth. So what we want to do is just learn what are some of the things those platforms do uniquely. Partially, I'll be showing that. But since we only have an hour, I'll be showing that very quickly and speaking to it along the way. I need you to pay really full attention, if that's OK. All right, lots to say. Considerations that we'll talk about, things like deployment scenarios. So a single container instance versus load balancing, and then orchestration platforms at scale. So that's sort of the progression that we might think about with Docker solutions. And then we're going to talk about the features that would be related to the orchestration platform that you might care about, which would help you to decide, do I need these types of things? And is there another workaround to those things until I'm ready to go full-blown orchestration and invest in the effort that it takes to get there? So in approximately 6 minutes, we'll do a Docker container lifecycle, we'll do Docker composed networking, we'll talk about deploying containers and use a simple example, and then we will get into scheduling and constraints, an important feature of orchestration platforms, and we'll use Docker Swarm to look at that. And we will look at orchestration management UI just sort of from a high level in order to explain, hey, these clusters actually usually need UI to show you what's going on inside them. And then, of course, all of those platforms give you visibility into that in different ways. They each have different tools, different UIs. So we'll talk about load balancing and discovery and see that UI with DCOS. We'll talk about recovery and self-healing and autoscale, and we'll see the UI, therefore, with Amazon and Google Container Engine, but also think about that as Kubernetes, which doesn't have to be deployed with Google Container Engine. It can also be deployed on Amazon or Azure or on-prem. OK? All right, that's a mouthful. Let's continue. So the first demo, we're going to talk about just Docker 101 and some of the basic things we might think about there. So I'm going to come in here and just what I've got installed on my machine. This is my Mac. Earlier I did a talk on Windows, so I was on my Surface Book. So I have Docker for Mac installed here instead of Docker for Windows, obviously. And so I have access to Docker from my terminal at this point, right? So what I'm going to do is I have no containers running, showing you that. And Docker images, we're going to see I have just a node base image that I can use, OK? And so I'll give a list here, and we're going to go into my Docker. And what I have here are an API and a website. I've shown the same demo in different ways. I'm kind of repurposing that and just showing that you can have 2 containers talking to each other. And what I'm going to do first is go in here and look at the API. If we take a look, you can see that I have a Docker file. And let's take a look at that. And that Docker file is essentially saying I want to use the base image for Argon, which is a lightweight Node.js image on top of Linux. And then we're going to copy over my source. And then we're going to do an npm start at some point here. There you go. And that's about it. So that's my Docker file. What the app does is really, it's an API, right? So it exposes some endpoints. So what I'm going to do first is just go ahead and let's build that. And if we take a look, Docker build is just going to go and build it for my DOS Blonde Docker Hub registry. So I'm using the convention of targeting with my tag the registry that I'm planning to push to, right? So that's typically what you would do. Obviously, there's different types of registries that are going to be touched on as we talk. And when I go and build this, it will just go ahead and try and rebuild the image. It will be an immutable image with my source running on Argon as a base image. And once this is built, I can go ahead and run it. So let's go ahead and take a look at a run. And what we'll do first is just run it. So I'm going to expose port 3001. And let's go back one more. And we're going to call it API. So my DNS for this one will be just API. Okay? So now my Docker PS, or Docker, it will show that I have API up and running. And you can see that it's running at port 3001. I should be able to now browse. So let's go into one of these guys. And we'll go localhost 3001. I don't really have anything exposed at the root, so I'm going to type speakers. And there we go. Bunch of stuff, so we know it worked. That's good enough for me. So now we've got an API running. What about my web app, right? So I'm going to go backtrack here, and I'm going to go into web. And let's go ahead and do the same thing. So this time I'm going to do a build, and we're going to call this my web build. We're going to tag it with DOS Blonde, content-web. That would be where I'd push it in a repository. I'm going to hit enter, and that will build the image for web. So once I've built that image, of course, I'm going to run it, and then that image is going to try and call the API image. Will it work is the question. Anybody? No, it's not going to work because I haven't set up a network, and I haven't done a compose up, and so it won't know how to reach the API, right? So what I've really just done is run two separate containers, but because when the web runs in its context, it won't be able to reach out to localhost from basically the Docker environment, the machine environment. So I need to have DNS. I need to have them join a network. I need to have them to be able to communicate. And that will be something that also matters in an orchestration platform. They just handle it in different ways. Some of them provide you with DNS through load balancers that are part of the platform. You'll see that when I do DCOS, for example. And some of them require you to do some complex setup to achieve the same goal, like Amazon, for example, because they don't have that native concept. It's actually all infrastructure, so you have to set up more things. So this is just building the web app. And once it's up and running, we'll go ahead and give it a run. It's nice seeing red text fly by because you know something's happening. Plus, it's really super exciting. I'm very easily amused, obviously. And a 1, 2, 3. It's taking a little longer. So this guy walks into a bar, and he says, I'm not going to do that. It wouldn't be appropriate. All right, so whenever this is done, we won't build that image again, because that's enough of that. But basically, I'll go ahead and run it. I'm going to hit the API. It's not going to work. And then I'm going to drop back, remove the containers that I started, and then I'm going to do a compose up on a network. I could also manually start each of them. I'm not going to go through that process, but I could just start the API, create a network, start the API, and join that network. And then I could join the web app to the network as well when I run the container, and I provide environment variables on the command line as well. But instead, I'm going to put it all in a compose YAML file, and then it'll do a compose up, and it'll do it all for me. So, and we're about there. Good. Looks like it's close. That is some serious image building. Okay, let me do this. Tell you what, while we're there, I'm going to go to a different terminal window, because this guy can stay busy all he likes, but I still have other options. So let's go in here, and we'll go to Docker, And what I'm going to do is I'm going to cat this Docker compose file. And let's take a look at what I've got in here. So what I'm going to do when I do a compose up is I have a version 3 compose. I'm going to build the image, but it's already going to be built. I'm going to expose the same ports I would have. I'm going to have a environment variable override that tells it where the API is, traditional. And then I'm going to specify a network called Fab Medical. It's the fictitious site that this is. And so while this is going, let's go see where this other guy went or landed. And looks like we're done, yeah? Okay, so if I run this, this will run the API, which we already did. Now I'm going to run the web app without a network, and this will expose port 3000. So let's give that a good go and come over here, and we'll go to port 3000. So I still have 3001 for speakers, for the speaker endpoint on the API. This is the speaker endpoint we're trying to hit. It won't be able to get there, so I have no content, right? So that's that. Okay. Now, let's go back to Docker PS, and what we'll see is I've got these 2 containers running. I'm going to do my magical blow it all away, force quit of those so that they go, okay. And then I'm going to backdrop until I get to the compose level, and I'll do a compose up. Oh, excuse me. And we'll do that. Okay, so that's going to basically run and do the networking bit that I suggested. I guess because it's probably renaming the image, it might actually go do a rebuild. So we're going to let that do its thinking. In the meantime, one of the things that I guess I'm taking you through here is the fact that you can individually run your images, and that would be fine. I could go to a VM in the cloud and therefore, have Docker running on the VM, put one image up there, expose an endpoint, port 80, and that would be the only thing on the VM. It would be as if I had a web app, running in a web server. Only it would be maybe if it's Node, it's going to have Express as the reverse proxy and web server. If it were Java, it might be Apache. If it were .NET on Linux, it would probably be Kestrel, for example, in .NET Core. So that would be the idea. In this case, when we do a compose, we're getting, more than one composition application. And so when we run, we're getting multiple containers. And then we have to figure out, well, what are those ports going to be? So they can't use the same port. We would have to have port 3000, 3001, unless we have a web server on the VM that's knowing how to route, in which case we would set up more interesting routing rules at the web server level so that we could have WAC API and WAC web, for example. So all these manual things you'd have to do are completely automatable if you use, some sort of scripting for your cloud platform. It's just that it's not baked into anything like an orchestration platform might give you a little bit more out of the box, if that makes sense. And so we're thinking more about, hey, what is my endpoint going to be? I have to structure my task definitions or my compose files to know this is going to be my port for that thing, unless I get something called dynamic discovery, which we're going to see with DCOS and so forth. All right, so I'm going to let that do its thing, and then we'll come back to it. But that was my quick sort of super intro tour to get us some foundation. And once that's running, we'll show that it's working, and we'll all be happy. So Docker Compose will let me run multi-container applications, but what we really think about when we think about Docker Compose files is task definitions. Every single orchestration platform has the concept of a task definition. So, with Amazon, with Google, with DCOS, Kubernetes, there's always a service definition, a task definition, an application definition that essentially defines the things that Compose does. So a lot of times there's transformations between Docker Compose, which is native to Docker and Swarm, into these other task definition formats. What they're trying to do is describe what is the application, how many services, obviously any constraints and ports and things. So you can see that, part of that could be the networks, any volumes that you're mapping if you need to have an external volume from the VM. It could be environment variables, which we've seen. And then there's a whole lot of other configurations that might be platform specific. Like when we get into DCOS, there could be configurations for the load balancer on top of this. So you can extend Compose to do more things. Compose is native to Swarm. Swarm is native to Docker, right? So when we think about composition, we're thinking about, again, task definitions. Now, before I can deploy a task definition to an orchestration platform, let's just drop back again and talk about the images. I'm still, at the end of the day, building these immutable images that need to deploy somewhere. And when running locally, I have an image registry locally as part of my Docker, for Mac or Docker for Windows environment, so that I can run, from my local repository, if you will. If I want to deploy these to the cloud, I have to push them to some accessible registry. So maybe Docker Hub or Docker Store. Maybe it could be, Azure Container Registry. Things like Docker Data Center, now called Docker Enterprise Edition, actually have their own registry built into the platform. Things like DCOS provide the ability to run a registry as part of the platform, if you like, so that it's all contained as part of the same cluster of VMs. So the idea is, based on the place you're going to deploy, based on the tool you're using, there might be a natural choice for which registry we're actually going to work with, right? I'll use Docker Hub for demos because then it's just open and I have an open account I use for that. But in production, with your actual enterprise assets, you're likely to use Azure if you're in Azure, the Azure Container Registry. Amazon has its container registry for when you're in Amazon. Google has its. And then if you're going sort of native platform like Kubernetes DCOS, you may still decide to use the cloud platform choice, okay? So these are just things to consider. So ultimately what I'm looking for is a way to take these local machine builds from code to Docker image, and that immutable image now be something I can push up to a registry and tag. The tags are really important because not only do they indicate where they're going to deploy, probably compatible with the registry, but also they indicate things like, is it the latest version? What's the version number? What was the build it came out of if it's CI? What is this is this our latest prod release? Do we have a naming convention for what means it's ready to go to prod? And then that would be now a promotion of this image to, we're ready to release you. So instead of version 1 being the prod tag, it will now be version 2 has the prod tag. So we have these tags on the images that help me promote, okay? And so pushing to the registry is really as simple as doing a Docker push, for example, right? And I might have to set up the registry locally so I have the credentials to push to Azure or Amazon or otherwise. But for Docker Hub, I've already logged in, so that will already be accessible to me. In addition, I might just automate those builds. I might just go ahead and do a check-in or a commit, and that would automatically generate the images and deploy to my registry of choice, which I would have set up then as part of the pipeline for CI, okay? So that's the idea there. So let's go ahead and take a look back at where we were, which looks like it's done. So let's do a Docker PS. It looks like I do have my web and my API running at this point. Let's do a Docker network inspect fab medical. And it looks like I have a fab medical with a Docker API 1 deployed in there and a Docker web 1. So there's 2 containers deployed as part of this network, okay? Because they're deployed as part of the network, I should now be able to browse, and it should now show me some content, right? So now we're hitting the API because I had configured the environment variable to look at DNS to find the API under the name API directly, right? As opposed to localhost 3001, okay? Okay, so that's all working. Now let's talk about the CI part. So what I have here is, let's see if we can list. I'm going to go into the API here, and let's do a look at one of the files. So let me go into Sublime, and oops, let's do that again. Don't mean to make you dizzy. Okay, let's do this. There we go. Okay, so over here somewhere I have my Docker and API. So let's go into one of the files, server, not found, go away, please. I'm just going to change a file just to make it so that there's something different, okay? So nothing that we're going to be able to see because I'm just going to go through this quickly, but let's go into here. And now I've got this git diff or status. Okay, so we're going to do an add, and we're going to do a git commit, changed a message. And now we've got something to push, but before I push, let me just go ahead and go to our content API CI. This is my Docker Hub, and then here is my DustBlonde directory. So in my DustBlonde directory, I have this content API. I'm going to check into there or commit this change. When I commit this change, again, this can be done different ways with different registries, right, or different CI tools. But when I commit to Git, I've actually connected this Docker Hub content API CI, and it's got some settings that it will monitor with a hook the commits over on my repository, and it will go ahead and pull and build the image. So we're going to see a new image getting built, and it's going to label it with the latest. So again, these are just standard things you're going to do, not that you're going to memorize this process, obviously. That's pretty straightforward. And then over here, we can see the history of the builds, right? So somewhere over here, we'll get to, a day ago I have run this. So now I practiced this at some point, right? So if it doesn't work, it's not because I'm lazy. So I'm going to go back over here, and let's do a git status and do a git push. Hopefully still remembers my credentials, takes care of business. Okay, now let's come back to this. And at some point here, we're going to see this refresh and start building the next image, which it will tag as latest. So there you go. So now that I've got an image getting built, obviously that's not handling the deployment side of it. There's a lot to talk about on the CD side, because there are tools that I find really, really useful for managing container deployments once we get to the orchestration discussion. In short, what I would say is this. What you want to use is a tool that allows you to have sort of a holistic picture of all the things you're deploying to your container platform. So Rundeck is an example of a tool that I like, introduced to me by other folks that do that kind of thing day to day, so I'm not an expert at it or anything. But I've enjoyed that because it gives me a way to go back in history and see the container builds, or it can be multiple task definitions that we push to Amazon or to the container platform, and you can see that we went and pulled version 1.2 of all the images that kind of go in a bundle and done that push. And then if something goes wrong, we can roll back that whole task and go back to a previous Rundeck job and rerun the previous job, and it will go get those immutable images and replay. So rather than automatically just getting these commits, creating new images, if that feels chaotic, you can actually do it in a more controlled manner also from the outside in. These are just things to think about, right? So there's tools for both sides. At the end of the day, this is just showing that, of course, I can build images automatically, they are immutable, and I can start working with those. Okay, so let's talk about how we might deploy that service. So I did a commit, right? And I did build an image, and it's in progress. And right now I'm going to have a new latest image of this API CI. And one of the things I might consider doing is just going to a VM and doing a pull, right? So if I don't have a tool that automates telling it to do so, then I would have to go onto the VM and do a pull from the repository and then run the container myself. If I don't have an orchestration platform that knows how to run tasks, then something has to do that job. The simplest possible thing I can think of is a headless container platform. And although it's really early days for this, it's an opportunity maybe to talk about Azure container instances. So that lets me go right into the Azure portal and tell it a container to run, and then it will provision the VM. It's a small VM just for that one container, and it will run that as, it will pull that from the repository that I tell it to. So let me head over to that screen here, and we'll go into Azure. So what I have over here is, let's just let the screen refresh a bit. I have a Azure Container Instance namespace, if you will, or resource group, ACI demos. And in here, I've already deployed a couple of different images. One was a Linux one, and one was a Windows. So you can actually have these loose containers that just have a space to run, almost like a Lambda in Amazon or a function in Azure, except for that it's a container instead, so it can be any code base you like. So it's a pretty powerful concept that down the road you can imagine somebody putting management around stuff like that, and then you don't need a container platform. But we're not there yet. But if you just need to run some loose containers and have them scale, this is an example. So I'll use that as a pre-container platform idea. I'm going to go into the bash command prompt here, and we'll take a look. So that'll create a connection to the shell so that I can deploy. And this is just a quick way, instead of using ARM from outside and automating from, either Terraform or ARM or something like that. So I'm just coming in here just to issue a simple command. It's the same thing that I could do from a PowerShell script or something like that. And this is probably... And so while that's kind of thinking, let's talk a little bit about pre-container platform deployments. So this is an example of just go ahead and create me a container. So I'm saying AZ container create, use public port 3001, make it a public IP so I can reach it, put it in my resource group for ACI demos, and somewhere over here we're calling it content API 2. I don't have to do that. I can call it whatever I like. And then it's coming from the image DOS-Blonde content API. Probably need to do that faster, apparently. So this will just show how quick it can spin up, just like a function or a Lambda would. So we'll get that done. Another option that I might have in Azure particularly is this sort of PaaS idea around app services. So app services are managed, VMs. So you don't actually think about, managing the VM. You just have these tools for scaling out and in. But it's actually provisioned for you. And you can define the size and so forth. So it's a PaaS offering that gives you out-of-the-box platform as a service, basically, right? And now they support Linux containers on those, so that's a preview item. And eventually they'll have, obviously, the same for Windows. So the point is, it's not a container orchestration platform. It's just a VM that's ready for a container to get deployed. And that way, instead of you managing getting Docker set up, I'm just going to hit go before this gets out of hand. You would just be able to deploy and not have to manage the VMs, not have to manage orchestration. But you won't have orchestration. You'll still have to think about ports. I have a container on a VM. I can only use port 3000 once or port 80 once unless I have a web server to do routing, right? You still have to think about the topology of what gets placed in the VM. Now, this has done its job, so I'm going to scale out here so we can see what happened. And if I refresh here, I should see that it's already there. And if I click on Content API 2, it's super fast, right? So it just provisioned me with this IP address. So let me go ahead and copy that IP. And let's go browse to that IP. And I think I gave it port 3001, just like before. And at some point, this should then just return for me the same content that we saw before, because it's the same container. Something like that. Oh, you know what? Sorry. Let me just hit the IP first. Did I tell it to have public? Public IP? Yes. Yeah, possibly. Possibly. Yeah, because I told it to use that port, so. Okay, well, there you go. All right, so again, for me to not care about orchestration, that means I'm either doing this, which would be the ideal consideration, so that I don't have to worry about, anything but what port do I want, and let's just let you scale out. But then I don't have a management story. So now I have thousands of containers, and I'm missing something, right? That visibility, that holistic view of all the things. So that's where it starts to get complicated. If I was using app services, I'm saving myself the trouble of managing the VM, keeping it up to date, security patches, even updating and patching Docker. If they give me a provisioned Docker-ready app service, then a lot of that's done for me. That's great. And so it's saving me part of the trouble, but I still have to think about ports and what goes on the VM itself, okay? So just kind of painting you the picture, if you have a simple enough environment, and you're like a startup trying to save costs, for example, you might just want one VM and not even load balance. But obviously there's risks that come with all these decisions, right? So let's talk a little bit about that. So deployment looks like potentially, just a simple, Azure container instance like this new feature that we have available in Azure, or it could be an app service, which is really just a VM that's managed for you. You still have the considerations. If you go to Amazon, Azure, or Google, all of them provide ways for you to provision VMs without an orchestration platform and just put stuff on it. And they'll give you Docker-ready VMs, or you can build your own and have those be scale sets or autoscale groups, or depending on the platform, however they like to call it. And then I have to just think about how I'm doing the topology. So if it's a single VM topology, it's probably going to be, I'm trying to save money, and I'm thinking, hey, if the container goes down, I can restart it quick enough. I'm not going to worry about it. I'm not going to have anything monitoring its health and telling it to restart. I'd like that. But maybe I'm trying to save costs, so I'm just going to manage it myself. But is a single VM really okay? And the answer is no, right? Even if a container starts really fast, you're still going to be in trouble if you have customers that care and that might not pay you for your services, whatever it is you're hosting, or it has a bad image on the company and so on. So ultimately, what you really want is at least load-balanced VMs. So then we get into a situation where I might have 2 VMs, and each of them has one container at port 80. Now I can't use port 80 again, so I would have to host other containers on different ports, maybe have them called by the port 80 container, so I could have multiple containers on a machine. That's no problem. They just can't use the same port because it's a resource that can't be shared, right? Unless I put an Nginx or HA proxy to do routing, and then I have a port 80 receiving everything, and that is what's load balanced at the top level, and then inside we do the routing. Right? So I still have to sculpt a lot. I have to design, what am I deploying, what are the ports I'm using, but it gives me a model that's manageable and even automatable at some point. No orchestration involved, right? So nothing wrong with doing that. It still gives you all the benefits of Docker for development and the immutable image and the idea of I know that this works here and in every environment the same way. But we really need to talk about, even though it can work without orchestration, maybe we want to think about what can orchestration give me on top. So that's where the fun starts, because we have all these things to think about. Platforms, of course, I've mentioned already, right? Amazon, Google, Azure Container Service, Mesosphere as a platform that can be deployed to Amazon or Azure. Kubernetes, which is part of the Google Container Engine, but actually can also be deployed to on-prem Amazon or Azure. And Docker Enterprise Edition, which is actually the Swarm native, right, Docker native platform that is now, it's been around for a while. Actually, we did a deployment a year ago for customer prototyping, but it's come a long way. So that's going to start being a contender in the same space, right, if it's not already. So all of these are options, and they're not the only ones. I'm listing the ones that are the most commonly that I run into, but there's actually other options. And then you've got the infrastructure, managing the cluster, the management cluster, the agent nodes, proxy routing, discovery, what kind of load balancing setup do I need in the host environment, which Docker registry will I use. Not necessarily hard decision on the registry, but just a thing to think about. And then we've got the core features, right? So this is where we get into the meat of why do I need orchestration? I need, something that will allow me to deploy more services when I need to scale them, but not have to care about ports, right? So load balancing discovery. and routing. All of that kind of goes hand in hand. I need auto-scaling so that I can have server density, so we'll talk about that. I need self-healing so that if a container goes down and stops working, it will try to heal itself and start again so that I don't have to be watching. And give me tooling that does that automatically out of the box. I need to be able to perform upgrades in a reliable way, right, that doesn't actually bring the service down. So if I can't deploy the new version, then let's not tear down the old one, right? Let's keep the system alive and healthy until we're sure that we've lit up the new version. And then we've got, in general versioning, which I won't get into much here in this talk, but it's just the concept that I should be able to have side-by-side deployments as well, if I need to have versions that support previous and new features. Scheduling gives you the idea of, okay, so every orchestration platform has master nodes, or a master that is basically in charge of quorum and knowing the state and health of all the workers. So this master node, or that cluster, is using whatever its consensus algorithm is. It's different in the different platforms, in order to determine one leader, and then obviously ensure that if one of the nodes goes down, it can fail over and elect a new leader, and all that's managed as part of that topology, part of that platform implementation. So it's different for DCOS than Kubernetes than it is for Swarm, for example. And then things like Amazon, they actually don't let you see the masters, so they provide it for you. They implement that as a feature of the cloud, and so does Google. So you don't see it. You don't have to manage it. You don't have to allocate it. It's just there. And so you just worry about your workers, and the workers is where you put the containers. You always schedule deployments to the master. The master decides where can I put those things, and it deploys. So the easiest way to look at scheduling and constraints is just to look at how we would do that with Swarm. So I'm going to take a look at that. And again, this is just a quick visual just to say, hey, this is a Swarm picture. It's one of the topologies that could be deployed to you. And you can see it's got the managers, which is who's managing the health and state of the rest of the cluster, usually 3 to 5 to 7 nodes. And then we've got the actual agents doing work. So all of them look kind of similar. And what we're going to do is I'm going to use commands that make it look like I'm coming in from outside to hit the master endpoint, the master, in order to issue commands to schedule services. So we'll do that. And I'll use constraints like memory constraints, -m, to tell the cluster, I need to reserve 3 gig of RAM for this container. So that's another concept that starts to matter when we think about orchestration, is we don't let loose containers run around using whatever resources they want. We learn to estimate what they need when they're deployed. Now that's a hard job, because if you want to estimate, that means you have to do drills, and you have to learn the topology and how your services behave, and learn enough about their behavior and their requirements so that you can give good estimates. But what you're trying to do is constrain so noisy neighbors don't bring the server down. You're trying to constrain so that you can do some predictions on usage of all the things on the cluster, and predictability of available space to do, say, job execution of things that are queued up and waiting for resources. So that's sort of how that works. And it works that way across all of the platforms, but let's go ahead and take a look. So I'm going to go into my Swarm, and we'll go into Swarm here, and what I'll do is connect to, I have a Azure Container Service, has 3 templates, one for Swarm, one for Kubernetes, one for DCOS. So I deployed the Swarm template, and I have a cluster up there with 1 master and 3 nodes right now. Okay, so it's not actually a high availability cluster, because that's a lot of nodes. Okay, so what I'm going to do is I'm going to run a container. Oops. Yeah. So I'm going to run the Content API, and you're going to see that I'm looking for 5 gig of memory. Okay. So what we need to do is take a look and see if we can do that. Now, how I'm going to look and see what I've got on the cluster is I'm going to run info against the cluster. And what we're going to do is scroll up a little bit here. And you'll see that I have 5 images deployed to the whole cluster, as it says. There's 1 container, and there's 1 running. I've got 3 nodes. So there's 3 agents, one that's got 1 container running with 5 gig used and only 7 in total. And then if I scroll down, you can see this guy's got nothing used yet, and then the third likewise, right? So the idea is this is what the manager node is managing, is available resources. So when I run that same command again to deploy, it's got to find a new node. The reason that deployed so fast is because I've already downloaded the image, because if we had to wait for that, that would not be good. So, and if I run it one more time, it should work because I have 3 nodes, but on the last one, it's not going to work. So I'm going to start to get failure because it can't find resources available to deploy. Memory is just one example of such a resource. So obviously the ports is another constraint that's a hard constraint, right, on deployment. And other types of constraints we can kind of quickly go through. Oop. So scheduling means that you take, a description of what the service requires to run, which could be a compose file or a task definition, or in this case, command line args. Same idea, right? The run command is taking these args and doing something with it, and it's going to schedule the services against the master. The nodes that have availability will then pull the image and do their job to run the container. Master monitors the health, and if something stops, if the container stops, it will restart it. If it requires at least a minimum 1 or 2 running, it will try to maintain that at all times. So that's the job of the orchestration platform, right? Each of them has a mechanism for doing so. The constraints that you can use for deploying those services can be implicit, which is the physical like port, or it can be explicit like the CPU and memory and I/O requirements. So you're trying to contain the container so that it can, not, again, consume resources excessively. But again, it's probably the hardest part of working with orchestration platforms is that you now have to understand a little bit about how much should I give this container and how do I know it's enough? Now, you'll find out pretty fast if you didn't give it enough and you run in dev and test and UAT and stuff just not working. You'll get the proper error, right? Like out of resources, et cetera. But you have to do drills. This is what sort of means we have to do some really good practices as part of our plan in an orchestration, adoption of an orchestration platform. It's not just about that. It's about the whole DevOps story around it. It's about understanding how to recover from failure and really testing it out. It's about understanding what can push that container to the limit. Like we've had examples in Amazon where, we have, let's say, a search container that uses a lot of memory because it loads a bunch of information in memory so that it can give you like a Lucene result, like a shopping cart or something. And we had to hit that one hard to see how much do we really think we need to give it, because it's one of the heaviest containers in our solution, for example. So doing those drills is key, standard operating procedures around recovering from those, and tuning the system for that go live. And then that helps you understand how to continue tuning as things evolve, right? So it's not as bad as it sounds. It's just that it's not the same as, hey, why don't I just deploy that and let's see how it's going. So all of these resource constraints are parts of, co-locating potentially containers. They should always go together, or these should never be together, and other types of heuristics. So it's useful for helping understand the distribution of the containers across the whole solution and the whole platform. Now, another thing we're looking for here is server density. We're looking for the idea that I can have multiple instances of containers, and whatever space is available, fill it up. But if we don't leave room for upgrades, then all of a sudden, when I'm ready to do an update, swap out the red one for a new version, I can't do it because I have no space now. So you have to have some space available in CPU memory and so on, disk space, so that you can actually do upgrades, roll out updates, and roll back if something goes wrong, because otherwise you get stuck. So again, having space is important, but then you can use that space to run jobs. So I can execute a job that just spins up a whole bunch of services using whatever space is free, finishes off, and is done. And then if my other containers get deployed and start using more space, we start looking at scale out for instances of the nodes, or scale up by putting more density on each node to keep them busy. So Orchestration UI, there is a native UI for Swarm. It's called Docker Enterprise Edition, and it comes with a fee. And there's actually a new thing that just came out this week, which you can set up a trial for a one-day demo. And you can keep renewing it. So it just gives you a cluster waiting and ready to go. It provides you with a UI on top of Swarm so that you can see what are the services, what are the nodes, how much resources are used, things that you're going to see when I go into DCOS. So I'm going to spend more time on the other platforms right now, but just wanted to point out that that also is another example. It's more of the same, right? So let's talk about load balancing discovery with DCOS and Azure Container Service. So I mentioned Azure Container Service can have DCOS, can be Swarm, or can be Kubernetes. And right now, what that means is provision me a bunch of nodes. Here's my master. I want 3 or 5 master nodes. Here are my workers or agents, and those are maybe starting out at 3 or 5, could be 7, could be 9. It's a lot of nodes, right? But you're not doing this for like 2 containers. You're doing this because you need a solution. So load balancing discovery would be something that all of the platforms cover. I just figured it would be worth showing with DCOS. And again, it's going to be much of the same: masters, workers, all of that. This is what the resource deploys for you on the Azure Container Service template. So without a load balancer, what I might end up doing is I'd have a private agent with an API on it exposing at port 3001, and my web app would have to know what port that's at, and it would have to, maybe expose itself through to the Azure load balancer at port 80. So there's no internal load balancer set up. This would be like a simple example of, hey, I'm not really taking advantage of, service discovery and load balancing and networking. What I really want to get to is this, where the question marks are, I don't care what port you are. I'm going to add 3, 4, 5, 7 instances of the API to handle load right now. And as that load is required, it doesn't really matter because the front end just needs to know what is the port that the load balancer looks to for accessing all those instances of web or API containers. So it should be fairly automatic, and that's kind of what I figured I'd show quickly with DCOS, which ignore the slide. So let's go to DCOS. And we'll go here to there. Okay, so I have a tunnel instruction. So I've already got a cluster up there. I've already deployed a couple things. The web app and API that we already know and love is up there, ready to go. And the way that I did that, I'll just quickly show you. So the DCOS is, what I'm going to do is run this tunnel, and that will allow me to go through localhost port 4555 so that I can hit it from outside and see the management UI that's presented. So I've opened that up to my machine. So let's do this. Oops. So we'll do tunnel. And there you go. So let's go to DCOS. And DCOS is going to show me things like how many nodes do I have, how much memory and CPU and disk am I using. Notice it's a flat line. That's because I'm telling it how much each container needs. It doesn't vary. It's saying, I need this. It's a reservation, right? So we reserve what we need. Kind of go down here, you can see how many tasks are running on each, how much CPU is left on each node, and so on. And what I had done is I deployed a service. So I went into the universe and I deployed a package for Marathon Load Balancer. So I installed the load balancer that's part and available to DCOS. So there's other packages as well, right? So Marathon Load Balancer, right? So I already installed that. In fact, I installed 2, one for external and one for internal use. And then for services, you can see I've got all the services running, but if I wanted to deploy a new service, right, I could go here to single container, and what this should look like to you is a compose equivalent, right? It's essentially a task definition, a service definition, and it's going to ask me things like, what do you want to call it, API2, what's the container image, DOS blonde, WAC, content, API, for example. How much CPU do you think you need? Again, these are the kind of best guess that you start with, and then you start thinking, okay, how do I drill it? How do I see if I'm going over? And then I'm going to go in here and set up things like networking, like am I going to be part of the bridge network? Probably. What are my endpoints? Container port 3001, et cetera, et cetera. Or I can go to the JSON editor and I can paste that, or I can post that, through obviously the Marathon API. So it's still just this. It's a task definition. It's saying where to get the image, how many minimum instances I want to have running all the time if I want to supply that, and what are my constraints, how much CPU do I need, et cetera. And that will start to sort of populate the nodes and leave less resources available. So I've already gone through that process, but let's go see an actual service running. So I'll go over here and we'll cancel, or discard. And let's hit up the actual service. So here's my API. And if I go into configuration, and I come in here and look at edit, this would have been what I deployed, right? So again, we don't have to inspect it in great depth, but just to give you sort of a taste of all the features, this is, the Docker image, this is my container port, and this is my service port. So this is where the load balancer comes in. I can now add as many instances as I want of the API, and then the web app is only pointing at port 10,001 at the internal load balancer. So that load balancer will handle for me that automatic sort of scale out and networking and discovery capability, that load balancing across the container instances, which I'm looking for. And so to take a look at that, what I would do is go to my service, and right now, let's go to instances, and this is actually showing the task that's running, so I'm going to go back one. Okay. And what I can do is scale it. So I can add, like, say, 4 instances and scale the service. And what that will do is schedule to scale the 4, and as long as I have enough space, enough resources available to do so, it will schedule and deploy those. If it didn't have enough, it would continue to try to deploy it until resources are available, and I would get notifications that things can't schedule, same way as Swarm did. And rather it being an error that surfaces and blows everything up, not that Swarm does that, it also has recovery mechanisms, but it will just surface as keep retrying, like pretty much forever, right? It's going to go into waiting state until resources are finally available. So this will try to deploy, and if I look at deployments, it should show my instances. Is it not doing that? Interesting. Scale. Interesting. Oh, okay, so it is. I'm probably just having refresh issues here, which could be happening. Or the pipe broke. No. Internet could be faster. Okay, so there it is, 4 instances. So I'm not getting the refresh fast enough to show you, but that now has 4 task instances running. Now, what's interesting about that is the app, if I actually go and run the app endpoint, so I think it's this guy. This is DCOS. And what I need to do is go over to my DCOS. So this is my cluster in Azure. When I provisioned it, it actually did all this stuff for me. It deployed, public IPs and an agent pool and a master pool and so on. And if I look for my agent load balancer, probably up here a little bit, agent IP, this will give me my DNS name that I need to hit. So this is the DNS that I should hit to get to the web app. And it should hit speakers and be able to show me the speakers because it's already set up to hit port 10,001 to find any of the available 4 APIs somewhere in there. Loading slowly, perhaps. Was working. Still loading. And then I also have a stats page. That might be a better one to hit. So my stats page will show round robining through, stats plural. There. So in my stats, you can see the task ID. That would tell me if that changes which instance it's hitting. So if I were to refresh, task ID should change. So this is now ending in 7A, and eventually it should round robin between the different instances. One of these moments. So, or it could be changing at the front and I'm not noticing, but the point is that I did this just so that we could track the round robin between each of the instances. So I think this did change because it was 8.8 before, so now it's D8. It's just ending the same 7A. So you can see a bunch of different task definitions, and here is what it was bouncing between. So the point is, when we think about the orchestration platform, scheduling is one thing. The other thing is load balancing, discovery, and the ability to deploy more instances and not care about stitching, container, ports and things like that. Just have it be accessible through some load balancing capability. You can do the same in Amazon. It requires setting up the ALB to do so. So it's a bit more infrastructure as opposed to internal to the orchestration aspects, because that's hidden from you in Amazon. And in Google, interestingly, you don't even think about it. You just say deploy a service, here's how many I want. You don't even see in Kubernetes, you don't even see the networking aspect. You just say I want it to be a service, and then as you scale it, it automatically knows how to stitch up to the DNS, so it's kind of invisible. Doesn't make one better than the other, really. I mean, it's just each of them has these little things they do in an interesting way that might be pleasant, and then there's other things the others do better, right? Or have a better UI or a better experience or better monitoring visuals and things like that out of the box. So you can ultimately achieve the same thing with all of them, okay? Okay, now on that note, we were talking about scale, and we were talking about load balancing discovery. Healing is another one. So in DCOS, if I were to have a health endpoint on the API that failed, then it would restart that task. And if it keeps failing, then it would keep trying to restart it to infinity. And I'd start seeing a lot of failed tasks, and that can be something I alert on. The idea around the platform is if a container fails and you're indicating I need at least 1 or 2 instances, then the law of the land is you have to restart it, right? So if I say I need 2 instances and both go down, it's going to try and start 2 more. And it will continually try to do that. But if I have a fatal failure, like I can't reach the database the API needs to run healthy, and my health endpoint's checking that, then it may not come back up until I fix the problem down below. And so that's the idea, right? So we're going to have this concept of self-healing and recovery from things. And then the autoscale part is really more about I have load. Maybe I'm hitting some sort of CPU or memory threshold, and as such, what's happening is I need to scale out either the physical nodes, or before that, maybe fill with more density the actual nodes with the container instances, so that we're making the most use out of the VMs that we have available right now. Likewise, things like I want to run a job and I need to read some queue and process. If there's available resources, it can run and do that work. So let's take a look at Amazon and Google Container Engine for that. And again, this is just a picture coming out of Amazon that shows you with ECS, you don't see the management cluster. It's just part of the Amazon hosting environment. So that is there. There is always a management cluster that's monitoring the health and state of the ECS nodes, but you're now just dealing with the actual VMs themselves for the agents. The same thing goes for Google Container Engine, but Kubernetes as a platform, just like DCOS and Swarm, when you deploy those, you get the masters and the agents and nodes. So it's important to understand that once you start doing that, you're going to pay for both sides. You're indirectly paying for both sides in Amazon and Google, just that they're hiding the complexity of having to manage them here. So you're not managing Zookeeper or Etsy, it's under the covers, instead of you having the cluster and having to care for that health. So obviously there's some desirability in that, no question, right? Something nice about that. When we look at things like Amazon, we're going to have possibly an ALB that does the load balancing. So this is just a picture to give you that idea of the load balancing and discovery. How would I set that up? I can do that with ALBs. So I can start deploying additional containers, and they'll stitch up to the ALB. And there's a really long-winded way to do that. If anybody's interested in the tutorials across all 4 of these platforms that I do in workshops, you're welcome to email me for that, because I don't make it public, but I'm happy to share it with people here, because we're kind of covering all of them. It's actually kind of fun. You go through the same process with every platform. So it's kind of, hopefully it still works across all of them, because of course they change, right? So what I'm going to do is I'm going to go into Amazon, and let's say a couple things. So let's go to over here. OK, so I'm going to go to EC2, and I'm going to take a quick look at health and recovery. So right now what I have is this web task here, and you can see I have desired task 2 and running task 2. If I go to the tasks, and I take a look at one of these web tasks, and I select it, and I stop it, then what that's going to do is take away one of my healthy tasks, and it's going to show me that I have 1 running task and desired task 2. The whole idea of self-healing is that my task definition is saying I want desired 2, and I will allow scale-up of double that, for example. And so, again, these are things that you might configure in any of these platforms. All of them support some variation of this. And so what will happen is, as I refresh, it will go ahead and replenish that. And eventually what we'll see is that there's 2 again. It won't take very long to get there. In fact, the refresh might take longer than the actual act. So that's one thing to consider. So we'll see that is going to recover on its own. The other thing I wanted to show you is I can actually go to this web app. And right now I'm running Health Web 7. So I'm running version 7 of my task definition, which does not require a health check on the API. And so what I'm going to do is I'm going to break it. I'm going to go in and do an update. And right now, Health Web 7, if I go to Health Web 8, it's now going to expect the API to return healthy, but I'm going to have the incorrect URL because I'm going to forget to put the environment variable that tells it where the health check is, just as a way to illustrate the kinds of failure that could happen. So instead of failing on the other side, I'm failing on the client side. So I'm not going to be able to validate health, and so therefore this is going to be failing. So right now, I have task 7 deployed with 2 instances probably again. We'll go check. And then I'm going to try to deploy version 8. So it's going to try, and if we go to view the service, it's going to try to deploy the next version. So you see it's over here. Health Web 7 is running. And somewhere, let's go back up. There we go. Yeah, so you see it had 2 again. And you can see pending. So it's pending on 8. It's never going to get successful. So it's just going to keep retrying until I do something to say, let's stop this nonsense. So it will pend, it will try to run, it will fail immediately, and then therefore 7 is the one stitched to the load balancer until 8 comes online. Since 8 won't come online, we won't get there. So what I'm going to do is update again. And this time I'm going to update to the version that fixes the problem. So I'm sort of simulating that immutable task definition also, and I'm progressing through what could have happened in a real scenario, right? So let me go ahead and update that service, and then go view again. And this time it will show that it's trying to launch the tasks. It's got 8 running. That's going to fail, right? It'll show running for a sec. It just won't stitch to the load balancer until it's verified as healthy, which it won't get to be healthy. So this is just showing that process. And if you look in the logs, you can see the history of that. Like you'll see that it stops and tries again. It stops and tries again. So it's all visible to you. So this is going to now come back and try to do 9. And then 9 will become healthy, and it will come online. Okay? So what I'm illustrating here is just, again, the concept of I can define how many I need to be healthy in my cluster. I need 2 minimum instances. And it will try to bring the 2 of the new version and do a safe rollout of that without tearing down what maybe the front end is looking for, right? So if this was an API, everything would stay up and running, waiting for the new one to come online. And so this is now pending 9. This will become successful, and once it comes online and is verified as healthy, it will go ahead and do retire 7, take it out of the load balancer and take it away. All the platforms support this kind of concept as well. So this is what you're getting out of orchestration. There's a lot of power, right, behind that, beyond what you would have had to do if you're just looking at VMs and manually stitching these things together. Now, the other thing that's really powerful is the auto-scale stories, right? So auto-scale in a cloud provider is going to be something that's usually provided on 2 levels. One is scaling the containers on the nodes to fill density, like we talked about, and the other is to scale the actual physical agents on demand. I'm not a fan of you have to limit your auto-scale, because I think when you have a peak or a burst that's unexpected, you can end up with 3,000 machines and pay a lot of money, and you weren't really expecting that. And it might be for the wrong reason, right? It could be sort of a red herring, something else that triggered it in the system. So in fact, you like to look at patterns and be monitoring that and have a sense of the peaks that come and go on a weekly basis, on a daily basis, on a yearly basis, and be prepared for those things. But waiting for autoscale to address it is often too late, because it might take 15 minutes for the scale out to even happen, and by then you've already got angry customers. So, relying on that alone, I'm just saying I wouldn't necessarily do. But filling the density of the containers, yes. And then potentially doing, some autoscale with an upper limit for this unexpected situation, and that's how we define it, for example, in Amazon. We would say only scale by 200% of what we have now, or 100% of what we have now. So if I were to refresh this, it would probably show me that 9 is online and 7 is gone. But I don't think we're having a lot of luck with UI refresh. So, ooh, that was unexpected. So, there we go. So, okay, so what I was going to do is actually take you to Google, and let's go and take a look at the Google Container Engine dashboard. Because what I'm going to do is I'm going to run a load test against Amazon, and that will take it through a scale out and a scale up. So it's going to actually density of containers, and then it's also going to do a scale out. Now, we're not going to wait for it. I've got screenshots that show that it happened, but I just wanted to get you an idea of how that starts with monitoring and watch. So if I were to come into Google, you can see that I have a, in my Google platform, I can see my Google Container Engine. I can come in here and look at the workloads or the clusters that I have. I have a cluster for dev and test and UAT and prod, for example, or other heuristics. I've got web API and content API deployed. When I deployed these services, the discovery and load balancing was taken care of for me, so I didn't have to think about it. Again, it was a service description, but I didn't have to say anything about load balancing and stitching. It just by default gave me a public IP and stitched, DNS in for me so that the web app could call it. So each of these is basically just a service with a service description, as you would expect, that gets deployed. I might not come in here to do that description, and in fact, normally I'm not going to come to this UI at all. This is my holistic picture of Google Cloud, just like Amazon has its for Amazon and Azure for Azure. But what I do want to do is go to the Kubernetes dashboard to see things. I don't think that's running right now, so what I'm going to do is we'll go into kube control. This will show the pods that are running right now. So I've got actually, the API and web both running. So I've got 2 instances of each. And if I do a kube control proxy, then what that will do is serve up on 127.0.0.1 so that I can refresh over here. And now I have my UI for Kubernetes, what I would get in Amazon and in Azure and everywhere else. And clearly, I'm going to go a few more minutes over time because there's 6 platforms in an hour. But maybe you can actually forgive me that because, that's almost done. So what's going to happen here is I've got Kubernetes up and running, and now I can come in here and I can take a look at deployments that have happened. I've got my API and my web. I can scroll down a little bit and look at the services from that perspective, and it will talk about load balancing endpoints and things like that. I can come in here and look at pods, which is really how you couple multiple containers, and it gives me overall usage. statistics and other details. And what I'm going to do is I'm just going to go ahead and run the load test here. So let's go to here, and that's my swarm, that's my G cloud, there we go. Okay, so apply. Oops. There we go. So is my load tester in that directory? Yes, I think so. So what I'm going to do is I'm going to apply this load tester. What it's going to do is deploy multiple containers that's going to hit Amazon with 1 million requests. And so that's going to start this scale-out story over in my Amazon app from Google. So I just figured I'd use both. This is deploying what's called a job in Google, so it's going to finish and be done, as opposed to a container that you deploy that has an endpoint and stays alive and must always be present. And again, all the platforms have their sense of how do you configure jobs as well, another type of orchestration workload, right? So now that that's running, I'm going to head over to Amazon, and I'm going to take a look at my CloudWatch. So let's go to Services and CloudWatch. And what we'll see is that I've got these alerts set up for when we hit a certain amount of memory. So because the containers are getting hit by Google and there's 2 jobs running at frequency, then these alerts are going to start going off. And again, I'm not going to wait to show you those, but I'll give you the screenshots after. That what it's going to do is lead to my container services. So if I go to my clusters, actually go here. Oh, there we go. And if I come in here, you'll see Fab Medical, 2 services, 3 container instances. What will happen is there will be the running tasks will increase to 8, 10, 15, and start to put load on the nodes, and then the nodes will have to scale out. So then I'll start getting more container instances, all because of those alerts and how they're configured to respond to the health of the nodes, okay? So that's just an example, again, of a thing that you could simulate to do drills on your services to see, can I make them fail? Or will my system actually healthily recover from all of these situations, okay? So again, stuff that you'll do no matter what platform you use to learn about the behavior of the system and tweak your service configurations. Coming back to Google then, the last thing I wanted to show you is we talked about health checks. I showed you a bad health, an endpoint that couldn't become healthy, that didn't deploy to Amazon, kept retrying, and then when I put the correct version, that's the one that was able to be deployed and retire the previous version to back. When we think about health checks, it's usually one endpoint. Each of those container platforms will give you a way to configure like a WAC health. And in there, you do what you think is best. Things like, is the database that I need to function there? Maybe some other socket checks or things like that. Now, with that said, one thing that Google does that's kind of interesting is they give you the concept of alive versus ready. And so the way that works is so alive is, have I got a real problem? Meaning I'm unhealthy. And ready is more like, hey, the container started, but we need to load some cache, we need to do some things, we're not ready yet. And so it's not unhealthy, you don't need to restart me, you don't need to recover that instance, but you do need to wait. And so I think that that's a feature that's kind of, desirable, and so I think it was just thought I'd give you a quick demo of that. So what this is my Kubernetes dashboard. I have these APIs, right? So if I go into the services, I have, this API endpoint, and then it gives me an external endpoint to hit it. So I'm able to hit that API there, and if I type something like, work, it's going to stay busy for a certain number of seconds. And if I go here and say cube control, let's just do get pods, it's going to show me 0 out of 1. So one of these guys is not ready right now. And it's going to end, and then it's going to come back to life. and you see it's already done it, right? So that was an example of I'm not ready right now because I triggered something that showed that it needed to do some loading. And that would be an example of I'm busy, I'm fully under load, but I'm going to be back later. So now let's distribute to the other nodes. And if I had all of them busy, I have to scale out. That would be another scale out trigger. But the other thing you can do is you can trigger failure, hard work. And so this is going to actually just fail, like 500's coming back, or in this case, it's going to hang. And so what would happen here is I can come in to pods, and I can see that that's readiness robe is failing. So I'm actually, not going to recover from this one, and it's eventually going to spin up another API because I have a minimum 2 required. So again, just showing you that all these things that we've just talked about are the things that we care about when we think about orchestration and platforms. So, let's kind of just wrap this up, and I'll try to, I guess, tie it together to decision making. So again, these are just the alarms in the slides to show that when the alarms go off for memory usage, I'm going to start adding more running tasks. And I'm going to fill the density of the 3 container instances. Eventually, I'm going to have 11 container instances because CPU utilization went up, and we said when that happens, we need more nodes. So then we added lots of running tasks, but across way more nodes. Okay? Simple example. This is a picture of the Kubernetes viewpoint where we have a master, again, master cluster. You don't see that in Google, but if you deploy Kubernetes to your IaaS environment, you will see that, of course, because you have to manage the masters and the agents. And then we already went through this. So just as a point of review then, I've talked about a lot of stuff and gone over, but you're going to forgive me that because there's a lot of stuff, right? Right? Docker without an orchestration platform, completely doable if it's manageable for you. It kind of comes down to that. Something will tip the balance where you'll start thinking about these features I showed you: load balancing, networking, scheduling, self-healing, auto-scaling and filling with density, running jobs, and being able to see the visibility of all that in one sort of pane of glass. So those are the features that drive you to think about orchestration. And of course, there's got to be business value, which I talked about in my earlier talk today. You have to have a business driver to bother with this, or else it's going to be a failed effort because it's too costly and time-consuming to get all this up and running, do the drills, understand your environment, know how to recover, disaster recovery, et cetera. And get that visibility into logs, too. You need your software to also be instrumented the right way for microservices. In the process of going through all of those things, what I've tried to do is give you a taste of, single deployments like Azure Container Instance, and then Docker Swarm for scheduling, Mesosphere DCOS for load balancing, AWS so you can get a sense of what the dashboard looks like and things you can do, right, managing tasks, and then Kubernetes and Google Container Engine, which are one and the same. So we covered quite a bit. I'm going to just say, I'm going to leave it there. But hopefully you enjoyed that. And, thanks for hanging out a little longer so I could get through it all. Okay.